welcome back. I hope for those of you in the room you had a beautiful lunch, and for those of you online, I hope you found some decent packet of crisps in the cupboard. You never know what you've got at home. So it's my pleasure to be here this afternoon leading and sharing this whole session, introducing and talking around all the great work going across the Catapult network, introducing different aspects of what we're doing, and also leading to some of the other discussions later on. I'm going to start with manufacturing because that's my area, and we're going to just talk through the afternoon and enjoy some discussions as we move forward. So really this afternoon's all around champion innovation. There is lots going across the Catapult network. I think some people sort of talk around death by PowerPoint. I'm hoping this afternoon's death by case study, showing and shouting about all the great work that we are doing across the network, try and inspire you and understand where actually you can innovate in your work and actually achieve the things that you're trying to do within your organizations. So as always, there is the hashtags available for getting involved, and there's also Slido. So we will be taking lots of questions throughout the afternoon as well. Daniel will be managing that at the back, and then there's also access as well to engage as much as possible. And if you do need it and you're not on there yet, there is the QR code. So moving forward, I'm Jonathan Eyre. I'm a Senior Technical Fellow based out of the High Value Manufacturing Catapult, and across the UK we are delivering excellence in everything we're trying to do within manufacturing, as well as engaging with the rest of the catapults where manufactured things enter the built environment and they interface with the healthcare system and all of these things. So it's really a case of this is why we need to understand how we're developing connected digital twins. So for those of you who aren't aware, HVMC is across the UK in around 30 locations. We have around 3,500 engineers working with organizations across the remit, working and specializing within manufacturing. And we're here, like many of the other catapults, all delivering the same message of how we can accelerate the economy within these areas. So we've all seen all the marketing around digital twins. This is a great one if you can't mention not jet engines. But I'm not going to dive into the marketing. And what I'm going to dive into, there's lots of types within manufacturing, and actually these are starting to become more and more mature. We've got the asset twins where we're gathering the data and understanding it, not just both from in-flight data. We've all heard enough about that case study. This is about the maintenance and the operation that you can need to do when you've designed it. What data do you need off the shop floor for your process digital twins to enable you to have digital thread, digital passport, all of the other terms needed to actually maintain the system? If you've needed a slightly different piece of pipe work or inspection process while doing it as a non-conformance, you need that data for your twin as much as anything else. And it's really trying to say, you can produce these all day long marketing images, but we need the evidence, which I'm hopefully going to show you in a little while, to actually how we move forward. So manufacturing's a bit of we all think we're all special snowflakes in our different sectors. We've been advocating for industrial revolutions for what we're trying to move forward to. And the latest within manufacturing is a sort of coined within Germany is Industry 4.0. It's actually based on the first industrial revolution, gradually moving through. So we started with mechanical power, moving through into mass production. Eventually, we get through into automated systems, robotics, control systems, program and logic controllers. And eventually now, when we're talking around modern manufacturing, we're talking around distributed systems, connectivity that we've not seen before. And actually, if we're being honest, a lot of our manufacturers are still Industry 2. They're still on paperwork. They're still really not automating where appropriate. So when you start to look at the advancements that have been made in things like AI, we always need to be conscious of how does that affect the majority of our market, the SME marketplace. So we all see all of these different aspects of an Industry 4. We all see them as individual technologies, which you start to look at how do they interface? And really, if we're not understanding how they connect, how are we going to achieve digital twins? So lots of buzzwords, let's be honest, for some of this stuff. What does it actually mean in practice, which I really hope to talk around across this afternoon. And once you start to get that connectivity, you start to end up with a shop floor in our space, which needs that distribution. And when you have automated AGVs, when you have machine tools that are producing goods, when you have swarf bins being taken off metal shards to go and be recycled, need all of your twins. So today, when we're talking around these big grand challenges of Credo and the great work going there and all the other aspects of connected digital twins, what about the twins and the connectivity you need in your own organizations? Why don't you advocate for having a twin of the people in the office so you can understand how you can react to events? It's still that ability to synchronize with the information you need for your role to achieve your business processes. And really a case of look down how you can enable your twins and understand that needs to advocate for your own implementations as well. So I think that's a much more realistic picture than the jet engine, because that's what we're dealing with daily. The ability to connect distributed data sets even within our own organization. And we've all seen these. Quick show of hands, apologies for those online, but how many of you all engage with these daily? And keep your hand up if you'd call those a twin. They are live synchronization into the world that's already in the consumer marketplace. They might be siloed in what they're achieving, but the vision of what they are driving is our interface. So why can't we have these in business and go, the best case studies we have of how traffic helps us navigate the world driving around, or whether we should get the bus or the train, has already proven case studies, and there are loads out there. The best case studies I can find for digital twins aren't called digital twins. They're called IoT connectivity platforms. They're called dashboards when they have the right data available. So actually, when people are going, I need more case studies, I'm like, what about the ones on your phone? What about the ones we already use when we're trying to drive forward? So we've all mentioned standards. I'm here to say, if you don't know which standards exist, go and read them. The main one is 23247, which is adopted as an international standard for manufacturing. That is a really strong framework that is advocating and understanding the terminology for how you go about creating a digital twin. And across the HVMC, as I mentioned, 3,500 engineers, the only standard and the only definition we use for digital twin, and you can hold me to this, is 23247. That is the language we are using and advocating for of a simulation is in there, analytics is in there, connectivity is in there. And we're using those terms in accordance to that's how we're describing digital twins. Part 1 is more of the top-level terms. Part 2 really jumps into the details of the entities around how they're connected. When do you need the connectivity? When do you need the dashboards? When do you need the business systems? And what it gives you is a lens, a picture of these are how to break down how the components need to work together. There's also as well Flex 260 for the built environment. This basically references 23247, so it's great, two sectors starting to join together. And actually at the bottom right, what they're advocating for is every sector needs to go through this process to go, strip out the word manufacturing, insert your own use cases, and it's probably good enough for your sector. So we don't need to keep working around because we're already basing on something that's internationally agreed. And there's another standard coming out more from the IT domain, being led sort of out of sort of Asia, sort of a marketplace. But again, it's driving back the same messages. So don't worry about defining your own language. People are saying we don't need standards, and I'm going, well, you don't need standards because they already exist, not because we don't need them. So what we've been doing within HVMC is looking at how we actually characterize and build on. So characterize building on the international standard and say, right, this is all the great work we're achieving within cyber physical infrastructure. So that's a newer term. We're all here about digital twins, but actually the much more broader remit is cyber physical infrastructure. Anything physically connected to anything virtual is actually the part of that ecosystem, which also accounts then for high-performance computing. It talks about networking, talks about all the things we also need to support the ecosystem of when we're connecting things together. So really it's a case of when we're doing this and moving forward, it's how we actually understand and achieve the use cases we want primarily, and must start with what are you trying to achieve as that use case. So I'm going to chuck up the standard, not because I'm going to read it out word by word, don't worry, but to point out that there are elements within this around how you digitally represent something and how you physically describe things. And the point of that is to go, I don't care where you start. You can start with a simulation model, and then when you need to connect it to an actual physical unique asset, crack on. And then I'm also going, as an SME, you have legacy tools, lathes, different tool systems. If you need to understand how utilized that machine is, put a current clamp on that machine and have a dashboard to understand how much it's being used. You both then get towards having a digital twin, but that's because a digital twin is an approach, not a specific technology that you can go off and procure. You can't just go, give me a whole platform which does X, Y, and Z. It doesn't exist on the marketplace. And if they are, I'd avoid them because they're selling you a load of lies. Like, there's great platforms which do the majority of the work, but the hard work is configuring it for your business requirements. And that's something that they can't tell you. You have to tell them and work with them to understand how you want to use that platform to achieve what you need to achieve. So this is a modification of the ISO standard looking at cyber-physical infrastructure. We start at the bottom of what you're observing, all the physical world. You start off with then moving into device communication. So how do you collect data? How do you control data? And actually what the standard says is you need one of those. You're either controlling it blind because you're not collecting any data, or you've got some way of getting a read-only state of the system. Then you're moving through into this sort of cyber entity or digital representation of what we're doing, splitting into three main areas. And then you've also got the top user entity. We so often think around digital twins, cyber-physical systems of the magic works, the AI is the silver bullet which solves all our problems. We forget that as engineers, as good engineers are, we innovate, we move forward, we accelerate what we're trying to do to solve the problems. If there's any way we're going to get to net zero, it's by innovating our way out of it. So if we don't have our interfaces, how are we going to innovate our way out of it? Now, I will say this diagram is a draft. We're still sort of in this final stage of publications, because at the bottom of the cross-system entity, like cyber, there's a physical aspect. There is this policy in place which says no USB sticks, please. And there's also the bit at the top where humans need to follow processes to go, actually, this is how we're using it to make sure it's secure. So there's lenses within this which still matter and work as way around, but what it has given us for now is to talk around the case studies we've produced, mapping it to this diagram to go, this is the great work going across the network, which I want to spend more time on. So I'm not here to say all of these are digital twin case studies. I'm here to say these are components that help achieve that vision of how we connect digital twins. So the first one is a piece of work done by National Composites Centre, looking at how they connect ovens, processes in place to look at the looking at the ability to cure carbon fiber. There we go. And it's a case of they've got the data now from their ovens, and they're going, well, actually, if the carbon fiber's already cured 2 hours in, why we keep running the oven for an extra hour? Energy increase and those sorts of things. So you don't need a lot of data for this stuff. So they've done more of sort of a thin slice looking through to actually sort of look at more of the root cause analysis of what they're trying to achieve, as well as then the main thing of energy consumption as sort of towards productivity. There's another piece of work by MNIS looking at analyzing complex models for looking at some of these systems. And this is purely, as a contrast, just a simulation. And I use that with the greatest respect to their work, because the detail they've had to go into, really looking at that simulation, is hard. But without that, how can you then say, well, once I've got the connectivity, here's how I can use it to then achieve part of that process. So some of it you can quantify more. And some of it goes, yeah, we can successfully model it. Who needs that on the marketplace? And that really drives home of these marketplaces we're trying to develop for data actually needs to have really detailed people who understand the finite parts of what they're trying to achieve. Piece of work done by MTC, looking at sort of test bench of analysis. So producing goods in small batches is actually, can we model how they're producing that batch at a much smaller level? Because once you incorporate the analysis of what they're doing within that process, they can then run that against the execution system, say, right, we're now producing a new batch. How long is that going to take? There is no process default time to understand, we'll just run it for an hour. Again, productivity improvements, running the analytics in real time. But what they're doing is they're modeling the data requirements, not here's all of the data, I hope it's useful by the time you get to the end of it. Nucleum RC have been looking at some of automated welding. So for those of you who don't know, when you're welding components, you normally have to grind back the surface afterwards. And actually, it's RSI that you get in the joints because you're holding a tool that's vibrating at time, and also the gases that's produced is really harmful for the operators. So actually, when we can scan and understand and do the automation process, you can actually then fully automate it. And this is a real point that we're doing across the HVMC is automating where appropriate. It's upskilling people in the jobs because they now become the robot programmer, but it's also a lot better for the operators because they're not even in sort of what's going to harm them as they go through those processes. And actually, big figures can be achieved, so 7% time savings, in addition to all of the benefits that you get for health. And it's looking at those use cases where automation is a lot more appropriate. Been doing some work at the AMRC as well, looking at digital work instructions and working with a jet engine manufacturer, and looking at actually, rather than it being on a screen at the far side of the room or looking at how you consume the information, can the engineers just tick off the roll as they're going forward? Can they work and understand, do I need a piece of text because I've done the job for 15 years? Do I need projection or a whole lens as a more traditional AR overlay to show you exactly where you're going through to new operators? And it's a case of looking at the skills. We often think of our skills, it's somebody else's problem. It's all of our problem. But as well as when we're looking at that lens and the competence needed, what do different operators need because of their skill level? It actually means you can have different end devices most appropriate to them of what's going to deliver the most business value. CPI, so the Centre for Process Innovation, is also looking at more of the pharmaceutical applications. So normally you produce a big batch. A lot of it can go to waste, depending. And then it's actually looking at more of how can we break that down? How can we look at the modularization of producing smaller batches, but also the key challenge there is cross-contamination. So how can we produce the batches and then not cross-contaminate, wasting all of the goods that are being produced? So sometimes you do need large investments, but it's only when it makes sense at the scale of what they're operating to prove out the concept. And finally, more towards the end engagement is a piece of work done by Warwick Manufacturing Group, looking at actually, can we monitor operators? If they're putting their back out all the time because they're lifting goods inappropriately, actually we need the guidance to support them all. So how can you do that? As well as understanding, are they going to the wrong pick bin to actually pick up the wrong component? So it's actually looking at how can we gather the information about them to actually drive operation improvements, as well as actually look after them as an engineer as they're doing the work. Because if we can say you're bending down into picking up things all of the time, actually the process needs to be refined. It's not their fault it's on the floor or not at the right height for them to work. It's the part of the process which can then provide those improvements. So sometimes we need the feasibility studies, as has been said in a few sessions, of try stuff, try and see if you can produce the data. I was in a workshop yesterday where they were going, we need to understand room occupancy. And it's a case of, oh, we need occupancy sensors. Like, no, you've got the number of devices connected to the Wi-Fi. That gives you a rough approximation of the occupancy of a room. That's good enough for most applications if you're trying to control your heating. And it's looking at the new ways of what data you need. So sometimes you just need to understand, actually, this is the data we can have, and then it can enable the new use cases. Small start, but a really important part of keep iterating forward, as we often talk about with software being agile. So all of those highlight different aspects of interoperability. They all talk around areas where we need to translate data from one thing to another and understand how you go about doing it. And the recent report from DCIT actually looked at interoperability as part of the sort of CPI consultation response. I just want to highlight this one thing of its physical interoperability, 4-inch pipe to a 2-inch pipe. How is that interoperable and how you move forward? It's the digital interfaces, the data, the software that we include, but it's also the frameworks, the commercial models, the supply chains, which is an equal third weight. We often just jump into one, but it's really broad in what we're trying to achieve, especially if you're looking at twins as a part of that approach to actually enable part of that going forward. So another piece of work, which was mentioned in the interoperability working group just before lunch, was produced by the GIG. So it's now part of NEMA, which was previously part of the UK BIM framework. Yeah, it's changed names for bits. But what they're actually doing is advocating for current best practice for interoperability on the data requirements. So things like, you must use standard date time, right? Sounds obvious. There's a way of describing date time in a contract. How many people actually put that into the procurement contract with lawyers to go, any data produced must use this format for date time? Well, unless you can mandate it and put it part of that, then you can't expect that when you receive that data. So it's actually a practical implementation of what's out there at the moment that you should be starting to specify at procurement level. This was focused around BIM, but a case of a lot of the technologies they've specified are already open from the technology sector. So it's a case of look at how they've classified it within sort of these 5 principles, so longevity, security, value, ownership, and competition, and start to break it down. Interoperability is still a massive word around we need it. Well, great, how are we going to get there? So they've classified it and then put technology recommendations against it. So a starting point if you're trying to understand what needs to happen in procurement. So what all that leads into is another initiative that I'm involved in is the Apollo Protocol. Now we often talk around cross-sectoral digital twins and how they're working together, but actually what we're not doing at the moment is advocating for having those conversations. What information do you actually need to have as part of that contractual agreement, as part of that procurement model, as part of that whatever file format exchange you need? So this is the mechanism of doing it, which I just want to highlight some of the work that we're doing across HVMC and what we're doing there. So we have a vision that we're looking for all sectors and industries to share a unified common language. Now, this isn't to say one file format by dictatorship. This is to say everybody needs to embrace the diverse nature of their data and all work together. So if you need a BIM format, an IFC, a step file, a JT, or whatever else, that's a supported file format. And even if you produce an Excel spreadsheet, and it's just your spreadsheet, you, by implicit ownership, take responsibility for managing that Excel spreadsheet. The trouble is, how often does that become managed by 100 people across the organization and no real formal support mechanism? So regardless of where your data lives, it needs to be embraced in this ecosystem of data management. And that's what we're saying. All of this interoperability of data formats need to understand how they all relate to each other and what we're trying to achieve there. Because if we don't get that right, we're really not going to enable the economy to basically not send files over email when it should really be API-driven and driven by the value in computer exchange of the information rather than relying on manual processes. So the position piece was produced around 6 or so months ago, just tail end of last year, and then we ran a sort of a series of successful events proving out the concept. So this starts to look at the benefits of the built environment and the manufacturing, but it was a starting point to then go, actually, this needs to be enabled across all sectors. So we're advocating for people starting and having the conversations needed to go, you need that information, I can provide you that information. Because until you get that, until you know what information you need, how are you going to secure it? How are you going to understand what you need to put in your procurement model rather than just going, give me everything and I'll dig out what I need? We need to get towards that for the computers to aid us rather than us relying on digging things out of a network drive. So the mechanism is to explore themes of whatever you want. We started with 4 as key main areas, and there's lots of working groups. We're not here to say we're starting around working groups. There's plenty of great ones at the DT Hub. There's plenty of ones happening in other sectors. To go, when you're having these conversations, you really need to advocate in a way of, we're exploring this, and we're going to publish and produce what we've explored openly so others can build on it. So the gig work I showed, quick show of hands. How many people knew about the gig? 1 or 2. So if they've already specified the open API specification and standard date time, how are you going to put that into your contract unless you can make sure that sort of open benefit is available and you can search for it by the computer systems? It is so complicated what we're trying to do, and often we can only think around and see in our heads the 3D world that we live in. And actually some people struggle to go, I'm going shopping tonight, what do I need for the next week? It's difficult to think in that 4th dimension of time, and then when you're saying safety, cost modeling, and all the extra dimensions you need in your data understanding, is it a surprise when actually we can't manage it all in our heads? So we've got a methodology which is about to be published, in a case of looking at how you're hosting that, the methods to go through it all, to say, get in touch, run the events, and what we're saying here is not you need to run it as a massive Apollo Perform commitment to develop the Apollo protocol. It's still your event, and it's the same commitment, just slightly more than Chatham House rules. It's a case of going, do it this way, and actually all together we can work on the big problems. So what we've produced so far is a series of sort of open engagements to understand and explore these themes around podcasts discussing each of the 4 themes, articles sort of writing up what we explored during the events. There's live illustrations around capturing the themes. And actually these have been really good to go, we didn't mention X. I was like, well, no, you go run in a forum and let us know what you think about X and where the issues are. Because you can only discuss so much in these workshops, and that's really bite-sized, churning away at these issues to go, this is what we found, this is the best way of looking at it. And there's also, of course, the National Digital Twin Network here at the DT Hub, looking at having those discussions. So at the moment, as we've been running the forums and sort of advocating for this message, we're growing a large community there, and we're looking for ways to start discussions on what you need and understand what's happening in the space. So please join the network. So final message from me around a lot of this stuff is embrace the impermanence of all of the data. A format you're using now might be gone in 2 years' time. And we need to respect the data that we're producing to actually understand how we're going to make sure that it's supported for the long term. If you produce, as I've mentioned, an Excel spreadsheet, you've got to make sure that can be supported by its use case. If it's a quick, which of my colleagues are doing X, Y, and Z, fair enough, keep that in your notes. If it's the new ERP system that you're trying to roll out, maybe you need to think more about its longevity around how that's going to change. And the whole premise is to learn by what other people have already done, adapt to what other best practices are already out there, and ignite the possibilities of what you're trying to achieve in your organizations. So if that's of interest, and you're thinking, actually, I'm already running events or looking at these ways of working, reach out. Like, we want these to be cross-sectoral events where we can understand the network of different initiatives, what they're trying to explore as we move forward, to run Apollo forums and actually get towards industrial agreed best practice of something we can all get behind as a protocol. So thank you very much for listening, and we'll take any questions. Don't think there's any questions yet on Slido, but any questions in the room? Stunned silence.
Jonathan, one of the challenges we find is just managing the complete diversity and maturity in this sort of field. So if we're trying to get organisations, sectors, twins to talk to one another, how do we reconcile the fact that some people are starting their journey and others are really mature and others are leaders?
Yeah, it is really difficult. And I think everyone's got their part to play in that ecosystem as part of producing those data models.
Yeah.
And there are going to need to be, as what people talk around, standard governance, there are aspects that do need to come down from the top around the top-level ontology as a sort of terminology around what are the absolute basics we can all agree upon. So can we agree upon data requires states? Sounds obvious, but if you've got two really disparate documents, even just understanding how am I dealing with 50 states or 5,000 states starts to give you that metric of how complex these data sets are. And understand that actually when you have a state, you can associate metadata to it. We can't even understand the metadata associated in a consistent way across different document types. So there's a lot of work going on in different aspects, actually looking at high quality data as a sort of concept, which isn't the most glamorous of terms, but it's realistic. And I think there's so much focus on chatbots and whatever else, and large language models, where they're going, oh, well, that'll articulate the problem. Well, until they can produce something in a format back which tells me, I'm quoting you this because it's an ISBN number, which I understand is part of a book, and then you can independently go and model that and understand, well, actually, let me check that book is real. Then how are we going to get towards these tools actually supporting us in our lifetime? It was really that drive towards it. Answer your question, Oliver.
Yeah, I mean,
it's a massive problem.
It's just a complex space, isn't it? Particularly when you look at the different levels of twinning. So Rolls-Royce is just so much more mature in thinking about what their asset twin is relative to one of their suppliers, where their asset twin is an Excel spreadsheet.
Yep.
So how do you get them to the point where they're providing one another meaningful information?
Yeah. We don't have the tools currently.
No.
Like, there's no way, and especially when so many of us are SMEs involved in the marketplace, like, how do they understand what data they need to produce? Because even if an OEM like Rolls-Royce specified, I need these different data properties off your data set, well, normally they get a drawing, they machine it, and they send it back and say, is that all right? Like, there's no real digital traceability of what they're producing because that's all they can do.
Yeah.
And when you start saying, well, here's not just a PDF, but a system you need to log into, and you need to provide that data back over an API, well, they don't hire software developers. So it's actually the mechanisms of articulating that as procurement and then the actual implementation of how you're actually going about practically working with the marketplace.
So isn't there really a need to try and bring everyone up to a minimum level?
Yes.
Rather than the small percentage of people who might become leaders and gold standards.
And that's actually where there's
themselves miles away from their supply chain and their customers.
Yep.
So you really need to bring the base up.
Yep.
To have any chance of really achieving the integration.
Yeah, and that's where there's a big difference between digital competence and digital skills.
Yeah.
And actually some of the skills conversations don't focus enough on that aspect of we all need to be digitally competent to actually use and interact with IT systems, but then you need the particular digital skills to work with those systems. So if you're using product lifecycle management, you need the skills within that particular tool set.
Yeah.
And actually what you're saying there is we need all the competence and then understanding where they need then the skills within the particular areas to actually enable them to do the job in the way that we need to do it. What's interesting in the, at least the manufacturing space, is they're looking at rolling out access. So the OEM owns the platform, but then they give user accounts and things to the SMEs so they work in their platform. because they know they're not going to afford the licensing costs or whatever else. So part of their overhead as part of running the process is they'll host the environment for them to input their data and then look at how it moves forward. Any other questions in the room? Yeah?
How do you deal with the challenge of seeing people having to retrain different skills? You gave the example there of the welding one. Expert welders are obviously quite hard to come by, right?
Yeah, yeah.
Okay, but that whole so that example is probably not the best one. But a lot of people, including various unions, might see this as an opportunity to get rid of lots of people from the supply chain from jobs, etc. So, in terms of how do we deal with that, what people might see as a threat to job, mass redundancy, those kinds of things.
Yep. So what happened in the particular example from Nuclear MRC is they worked with the sort of welder and grinder to get them to work and get trained up in robotics. So they're working with them to understand how would you grind this process, and actually they're being upskilled in that sort of aspect. Another aspect is actually people looking more towards micro qualifications, which is a bit of a fancy way of how short a training course can you make it? To go, can I just give you half a day or a day to give you enough of a qualification, enough of an upskilling area to be able for you to do a job in a different way? And actually, to answer your question more broadly, when Germany's invested in automation, again, they've done a lot more full-blown automation, they've actually seen a 30% increase in jobs.
Yeah. No, I mean,
that's a fine balance.
Yeah, I see that. Do other people? This is the thing that's, it is a big thing, isn't it? That we in other countries, like we see that as being true. How do we communicate more effectively here in the UK?
Yeah.
I think the opposite is currently the trend.
Yeah, completely agree. There is one online as well, just saying, is an engagement with Industry 4.0 and the Industrial Digital Twin Association. Yes, so I'm engaged with both those organisations in different areas, and there is a lot of work and engagement with them through the DT Hub as well, and even UKRI is part of an engagement with both organisations. So there is a lot going across the world, and there's a lot of engagement across both those areas. Any other questions? Wait.
Jonathan, what insights came out of the Polar Protocol hacks? Is there any information that manufacturers can provide to wider industry and wider industry looking for manufacturers?
Yeah, so just to repeat, the question was around what were the insights gained out of the Apollo Protocol. So the forums really highlighted people were able to come up with use cases, and when people say, oh, I've got 5 use cases for my digital twins, actually one of the things we found is we got about 150 in about 3 sessions. Like, it doesn't take a lot to come up with a use case. What we're not saying is you need to prove it straight away. It's going, I need access to this sort of data if I were to achieve Y. So actually one of the things is actually getting people started and breaking it down into the big areas that you can engage at different levels. Not everyone needs to be an ontologist or a philosopher to argue about physical data prototypes and everything like that. It's about trying to understand where we can best engage when we're trying to look forward to some of these things. Some of the other areas as well that came out were around policy and trying to understand what policies need to be put in place. So if we're looking at the big grand challenges of nothing entering landfill, we need a whole second-hand marketplace, and that infers, well, we need product IDs so we know what materials are in it. So there's actual recommendations coming out, which is going, what are the benefits and what needs to be done so we're all playing the same game? Because otherwise, fly tipping still happens because we're not able to trace them. Well, if you've got the product ID and you can trace that back through who bought it and what job that was part of, you can actually automatically find them. And it's a case of, well, actually breaking down and enabling aspects of that digital thread allows much more better intelligent systems where it just becomes part of the economic powerhouse that we have.